In this example, I have a 4 by 4 matrix, and I want to compute the reduced row echelon form of this matrix. So here's our matrix, and I want to start in that top left corner. So I'm looking for the first non-zero entry in the first row, and I want to turn that into a 1 here. Now, in this first step where we're turning something into a 1, there's a couple different options we have to consider. The first thing I might want to do is look to see if I have a 1 anywhere in that column. So if any of these entries were 1, the easiest way to get a 1 in that first slot is to just swap two rows. That's not the case here, so we have to be a little bit more creative. And one of the things I can also do is multiply a row by a non-zero constant. So I could, for example, multiply this entire first row by -1/3, and that would turn this into a 1. But that would give me a fraction here in the 2 slot, because I'd have -1/3 times 2, so -2/3, and maybe that's going to be a little bit inconvenient to deal with, and I like to avoid fractions when I can. We can't always avoid it in these kinds of cases, but if I notice the third row, then all of the entries are a multiple of 3. So if I multiply the second row by 1/3, that's going to give me all integer values in the second row, which is a good sign. So let's actually, instead of trying to get a 1 there, let's swap those two rows and then get a 1 in the first slot. That way we can avoid the fraction. So I'm going to start by swapping row 1 and row 2. And it's always important to label our row operations. That way we know what's going on. Okay, so the only thing that's changing is the first and second rows are swapping. So I have 3, -3, -3, 9, and then -3, 3, 2, -9. And then the third and fourth rows stay the same. So 16, -16, -18, 48, and then -3, 3, 3, and -9. Okay, so now I'm better positioned to get a 1 in the upper left corner because I can divide everything by 3, or really just multiply by 1/3, and that will turn this into a 1, and it won't introduce any fractions. So my next row operation, and I usually write them next to the row I'm changing to kind of help me keep track of everything. So I'll say 1/3 row 1 is going into row 1. So this is the row operation we're doing, and then the arrow says I'm replacing into row 1. Okay, so let's go ahead and do that row operation. Everything gets divided by 3, so 1, -1, -1, and then 3. And then the other rows stay the same. I'm not doing any row operations to them. So I'll have -3, 3, 2, -9, and then 16, -16, -18, 48, and then -3, 3, 3, -9. Okay, so at this stage, I have a 1 in that upper left-hand corner, so this will be a pivot. And I know that I want to have zeros everywhere else in that column except for the pivot. So I need to do some row operations to row 2, row 3, and row 4 in order to get zeros there. And here, I'm going to leverage the fact that I have a 1 up here. So I'm going to use row 1 and the row I'm trying to change. And since each of these are independent, they're all going to rely on row 1. They're not relying on each other. I can do all these row operations at once. So this will kind of save me some work here. So let's look at row 2 first. I start with row 2, the row I want to change, plus some multiple of the row with the 1 that has the pivot. So some multiple of row 1, and that will replace row 2. Now, what is that multiple going to be? Well, I want to take row 2, which is -3, plus some multiple of 1, and get 0. So -3 plus what times 1? Well, it's going to be the opposite of -3, or just 3. Okay, notice if I do -3 plus 3, I get 0, and that's exactly what we're looking for. So we'll use a similar pattern for the rest. Row 3 plus negative this entry, so -16, row 1, and that will replace row 3. Sorry, I'm running out of space a little bit there. And then in the fourth row, I'll have row 4, the row I want to change, plus the opposite of that entry, so 3, row 1, and that will replace row 4. Okay, so now it's just a matter of performing these row operations. So let's go down to the next line here. My first row stays the same. There's no row operations happening to it. So 1, -1, -1, 3. Okay, then we have to be careful with order of operations, right? We want to make sure the 3 is getting multiplied by row 1 and we're adding that to row 2. We don't want to do row 2 plus 3 and then multiply by row 1 because that doesn't follow order of operations. So here I'd have -3 plus 3 times 1. So -3 plus 3 gives me 0. Or it might be easier just to think about 3 times row 1 plus row 2, right? So -3 plus 3, that also gives me 0. And then -3 plus 2, that's going to give me -1. And then I have 3 times 3 is 9, minus 9 gives me 0. Okay, so that's our second row. Then I want to multiply the first row by -16 and add it to the third row. So -16 plus 16 gives me 0. And then -16 times -1 is +16. Positive 16 minus 16 gives me 0. And then -16 times 16, -16 times -1 gives me +16. Minus 18 gives me -2. And then 3 times -16 gives me -48. Plus 48 gives me 0. Okay, then in row 3, sorry, that was row 3. Row 4, 3 times row 1 plus row 4. 3 times 1 is 3, 3 minus 3 is 0. And if we did it right, that first column should be 1 in the first slot and 0s everywhere else, right? Because that's how we picked our row operations. So that's a good sign. Then 3 times -1 is -3, plus 3 gives me 0. And then 3 times -1, -3, plus 3 gives me 0. And then 3 times 3 is 9, 9 minus 9 gives me 0. Okay, so this one here is still a pivot. It's the first non-zero entry in that first row. And I have zeros below, which is perfect. Now I want to move down to the next row and find the next non-zero entry, which is this -1 here. Now I want the first non-zero entry in each row to be 1, not -1. So I can multiply this second row by -1 to turn that into a 1. So we'll do -1 times row 2, and that will replace row 2. Everything else stays the same. So 1, -1, -1, 3. Then this row gets multiplied by -1. So 0, 0, 1, 0. And then 0, 0, -2, 0, and 0, 0, 0, 0. Okay, so now I have the first non-zero entry in row 1 is a 1. The first non-zero entry in row 2 is a 1. It doesn't matter that there's that gap there, right? It still follows that stair-step pattern. The lower one is to the right of the upper one, which is perfect. Now, what I want to have happen is I want to have zeros above and below the 1 that I've circled. So I need to turn this -1 into a 0 and this -2 into a 0. And I'm going to leverage this circled 1. So the row I want to change is row 1 plus some multiple of the row with the 1 circled, so row 2. That will replace row 1. And I want the opposite of this entry, so 1. So basically row 1 plus row 2. Then in row 3, I want row 3 plus some multiple of row 2, and it's going to be the opposite of -2, so 2, row 2, will go into row 3. Okay, let's see what we get. So in the first row, I'm going to add row 1 plus row 2. 1 plus 0 is 1. -1 plus 0 is -1. -1 plus 1 gives me 0. and then 3 plus 0 gives me 3. Okay, then the second row stays the same. So 0, 0, 1, 0. And then in the third row, I have 2 times row 2 plus row 3. So 2 times 0 is 0, 0 plus 0 gives me 0, and then 0 plus 0 gives me 0. 2 minus 2 gives me 0, and then 0 plus 0 gives me 0. And then the fourth row stays the same, 0, 0, 0, 0. Okay, so now my first non-zero entry in row 1 is a 1, and there are zeros below. My first non-zero entry in row 2 is a 1, and there are zeros above and below. And they have this stair-step pattern, and all of my rows with zeros are at the bottom. And so this matrix is in reduced row echelon form, and so that will be our final answer here.